Hey everyone, welcome to episode 5. In this episode, we're going to go through how to install Klipper, how to configure it for a printer, and set up our Raspberry Pi, and flash it to a mainboard. So, the very first thing you need to choose when installing Klipper is what interface you're going to use. There are 3 common interfaces. The first one being Mainsail, which is what I use. There's another interface called Fluid. They are very similar. And then you can actually install Klipper onto a Octoprint install. We're going to just be talking about Mainsail today. Just know that Octoprint is nice if you want to use plugins. If you use Spaghetti Detective or any plugins like that, you will need to use Octoprint. Mainsail and Fluid don't support plugins at this time. As well, if you want to use a Raspberry Pi Zero, you do need to use Fluid or Mainsail. Octoprint is a bit too heavyweight to run Octoprint and Klipper on a Raspberry Pi Zero. It's just not fast enough. So we're going to talk about installing Mainsail today. So Mainsail is a web interface for Klipper. You can see I'm at the Mainsail web page here. They do have a setup guides for this, and we are going to be looking at the Mainsail OS setup. Mainsail OS is a pre-configured image that has Raspbian, Klipper, and Moonraker, which is the software used to talk to Klipper. We can go down to Balena Etcher. That's the actual program we're going to use to flash the image. So I have Etcher on my computer. Look that up. And I have downloaded the Mainsail OS. If you go to Mainsail's GitHub, which I have opened here, and go over to the releases on the right-hand side, you'll find the latest release for Mainsail OS. And I've downloaded the zip file here. So, if we open up Etcher, we just choose our image that we downloaded. Choose the SD card. I have a 32 gig one here, but I think 8 gigs is the minimum. And we'll flash this. So I've already done that. You can see that I flashed that because on my PC I have a boot drive here. This is the actual boot drive for the Raspberry Pi image that we just flashed. So if you are going to use Wi-Fi, you have to come to this drive and configure Wi-Fi in this text file, MainsailOS WPA supplicant. If you're not using Wi-Fi, you can go ahead, take the SD card out, put it in your Raspberry Pi, and just boot it up. If you're using Wi-Fi, we need to go into this text file and take out these 4 commented lines here. You can put in your SSID and your password here and save this config file. The Raspberry Pi will then automatically turn on and connect to your network. Please do pay attention to these. If you're using TextEdit on Mac, you must make these changes. Otherwise, it will corrupt this text file. Same thing for Windows. Do not use WordPad. Use Notepad or Notepad++. Okay, so again, come to this text file, uncomment these 4 lines, put in your SSID, and put in your password. Save it. You can go ahead then, take the SD card out of your computer, put it into your Raspberry Pi, and turn it on. The next step is very important. We need to find out what IP address it has assigned to your Raspberry Pi. To do that, you must have to go to your router. I went to my router here. I've logged into it with the username and password. Usually it's printed on your router, something like admin and admin or something like that. And in my particular router, I go to my connected devices and I can see Mainsail OS and I can see my IP address. Now I have 2 printers here, so I've already configured these, but we're going to go to this IP address right now and we're going to see which printer this is. So this is my Phoenix Mini, which we are using to actually set up. You can see now this is the Mainsail interface. And Mainsail right now is looking for a config file. It doesn't have one by default, and we need to give Mainsail a config. The next thing we need to do is go to the Klipper GitHub and actually take a look at the configuration examples that it has. So if we go to the Klipper GitHub, you'll see there's a configuration folder. In that configuration folder is a list of examples of mainboards and also examples of motion. So you can see here we have Cartesian, Core XY, Core XZ, Delta. Even Polar is listed here. If we go into one of these, so Core XY for example, this is a example configuration on how to get a Core XY printer running. This configuration does not contain any pin mappings for any real mainboard. This is a generic config just to show you what you need for a Core XY printer to run. Same thing for Delta. If we go to Delta, this is an example on what you need to put into this config file to get a Delta to work. So if we go back to this config, we can also scroll down here a little bit and we can start to see mainboards. These are config files for an actual specific mainboard. You can see my Big Tree Tech SKR Mini version 2 is here. There's the SKR 1.4 here. There's stock Creality boards. Duets are supported. The Fly board is in here. A bunch of Phytech boards or Physec, however you pronounce that. There's the Spider here, the S6, some older MKS Robin Nanos, these 8-bit boards, a whole bunch in here. You can also see though, there's also config files for printers as well. So for example, Creality Ender 3 is here. We could install Klipper onto an Ender 3 and onto the Ender 3's mainboard. Same thing for CR10s. I've done a few CR10Ss. I have installed Klipper on a Tronxy. There's Tronxy printers here. ANET A8s are on here. Lulzbots are on here. A whole bunch of different printers are on here. So what we're actually going to be doing is, because we're using an SKR Mini version 2 E3, we're going to be using this config file. So we're going to go ahead and take this config file here, copy it. We're going to go to our Mainsail, go to Machine, and we're going to create a file, and we're going to call this printer.cfg, which is what it's looking for. We're going to then go into this file and paste our SKR example, and we're going to save this. Klipper firmware is going to restart, and you'll see now we don't have an error message. It's waiting for Klipper to connect to our mainboard. It can't connect yet because we have not told Klipper what USB port we're using. So before we need to go to that step, we actually have to now compile Klipper for our mainboard. So we need to install Klipper on the SKR Mini now. So if we go to the Klipper website and we go to installation, we're actually going to be flashing the microcontroller or flashing our mainboard. So we need to use PuTTY for this. So I'm going to open up PuTTY, and we're going to have to put in the IP address of our Raspberry Pi. So let's actually go back to here. Here is my IP address for my Raspberry Pi. This is why it's so important to know the IP address of your Raspberry Pi. We're going to go to PuTTY. We're going to just type in the IP address though. It's not the URL, it's simply the IP address. We're going to click open, and it's going to ask us to accept a certificate. We're going to say accept. And this is the standard Raspberry Pi login credentials. So Pi is the username and Raspberry is the password. And you can see we've logged into our Raspberry Pi. Okay, we can now go ahead and follow the configuration steps outlined here. So we are going to change directory to the Klipper. I'm just copying it and I'm pasting it with a right click in PuTTY. We are then going to go to make menu config. And what this is a visual configuration tool to set up a firmware file for the SKR. So if I run this command, you'll see it opens up a visual interface basically. And I've already done this once for my SKR Mini, but I'll walk you guys through this. So if we go back to our example configuration on the Klipper GitHub, at the beginning of any of these Mainboard config files, it will generally tell you how to compile this for your Mainboard. So if we go to our configuration tool here on our Raspberry Pi, you can see I went through these steps. So it says the firmware should be compiled for the STM32F103. So I went down to my processor. I went to my processor architecture. So this is an STM32. There also is the Atmega board, so older 8-bit boards. There's a whole bunch of different boards here. We're choosing the STM32 as it says. The processor was already selected for me, STM32F103, which you can see here. And it's telling us we need to use a 28K bootloader, which I have set here. It's now saying USB communication, so that is configured by default. We can see the communication interface is USB. And it says also select enable extra low-level configuration options, which you can see is selected here with the asterisks. And then the final option here is GPIO pins to set at microcontroller startup. And you can see I've entered in that here without the quotations, just exclamation PA14. And this is only for the SKR Mini version 2. Each mainboard has its own configuration. So if we go back to the configs, we can find one here, for instance, let's say for the Cytec Spider. It has its own configuration here. It has a different processor. It has different options here for clock, all sorts of different things. Generally, this will have a guide for each mainboard. I find the SKR ones are very straightforward, but Voron and a couple other printers do use the Cytec ones. There's the Duet ones here as well too. Generally, whichever mainboard you're using, go to this configuration and it will tell you how to compile this. So if we hit Q to quit, we hit yes to save. We go back to our Klipper installation. It now tells us to run the make command. And it's now going to go ahead and compile a bin file for our SKR board. So we'll let this run. While this is running, we're going to have to actually install a program called WinSCP. And I've already installed that on my computer, WinSCP. This allows us to remote to the Raspberry Pi's hard drive, essentially. So again, we're going to use the same IP address for our Raspberry Pi. We're going to go into WinSCP, put it in here. Make sure you have SFTP selected. We're going to click Login. It's going to ask us to accept the certificate. We're going to say yes. Same username and password, Pi and a Raspberry. And now we have access to the file structure on a Raspberry Pi. The right-hand side is the Raspberry Pi. The left-hand side is my computer. So if we go back to PuTTY, it's finished creating a bin file for our SKR Mini. You can see down at the very bottom here, it was successful, and it's created a bin file at out/klipper.bin. And that is in the Klipper folder under out. You can see we have a klipper.bin. And you can see the timestamp is correct here. It compiled it at 12:43. So you can just drag and drop this over to the left-hand side and it will copy it to your computer. You can see I've copied one already to my documents. You can also see I've renamed the bin file to firmware instead of Klipper. And that also is documented too in the steps. You can see right here. We need to change the file name to firmware.bin, which I have done. So if we go to my documents, I've renamed it to firmware.bin. I can now copy this bin file to my SKR Mini's SD card, put it in, and turn it on. The SKR will automatically look for this bin file and flash it. It takes about 5 to 10 seconds. Once that's done, we can proceed to the next step of Klipper. We now need to tell Klipper, or we need to tell the Raspberry Pi, what USB port our mainboard is connected to. And what we're going to do is we're going to run this Linux command which lists all the serial IDs on the Raspberry Pi. So if we go into PuTTY again here, copy and paste this command, we can actually see an ID. If you don't get this blue ID show up, either the SKR did not flash the Klipper bin file correctly, or there's something incorrect in your bin file. So go back to your guide here on how to configure. Go back to Klipper. You can go right up to the top here again, go to Make Menu Config, double check that you've done this correctly, recopy the bin file, and put it on your SKR. Once you get this blue ID to show up, that's a good indication that Klipper has successfully installed on your SKR Mini. Okay, so we now have this. So let's go back to our Mainsail installation, our Mainsail website. You can see now we have a different error. Basically, Klipper on the Raspberry Pi is unable to connect to our SKR Mini, and that is because we haven't given it that ID. So if we go to Machine, we go to printer.cfg. At the very bottom here, or near the bottom, we can see our serial ID. This is just a generic one that we copied from the GitHub. So we're going to go to PuTTY. We're going to go into Copy, Control C, and we're going to paste this right here. Now we're going to go up to the very top right-hand corner, save and restart. And as you can see, we've connected successfully. Please ignore this. My mainboard is configured a little bit differently than the normal SKR Mini. You generally won't get this. However, what it's saying is one of my ADC ports is out of range. Basically, one of my thermistors is out of range. And that's specific to my configuration, so don't pay too much attention to that. I'm actually going to delete this printer config and I'm going to upload my configuration file, and I'm going to restart the firmware. So you can see now we've successfully connected our Raspberry Pi to our SKR Mini mainboard. You actually may get a couple warnings that show up here from Mainsail, and I'll go into here and I'll show you how to resolve that. I believe if we go into configuration, necessary configuration, you need to set up a couple things in your config file for Mainsail. So if we go back to our Mainsail interface, we go to our machine and we go to our config file, you can see I've already done this. So starting at the top here, I've set up a temperature sensor for my SKR board and my Raspberry Pi. I wanted to know what temperatures they were at. This is optional. You don't need this part. You do, however, need the next parts. So I've just copied and pasted what Mainsail told me. So I need this. I copied and pasted it, and you can see that right here. I've needed display status. I've copied and pasted that and put that in here. And it needed pause resume, and I've copied and pasted that into pause resume. This end stop portion is an additional configuration for Delta printers, which we'll go through later. And I've set up a couple macros. Another very powerful thing about Klipper is it's very easy to set up any macro you want. So I have a pause macro, I have a resume macro, and I have a cancel macro. And that's already documented for you here. There's an example pause macro, there's an example resume, and there's an example cancel print. I've copied those three things and I've put them at the very start of my config file. So you can definitely do that. So also what I've done is I have now changed my generic SKR mini config file to a Delta configuration. And this will take you a little bit of time to do that. I'm not going to go through that in this particular video because it could be for a Core XY or a Delta or a Core XZ or any type of configuration. Basically what I did was I went back to here and I went to the Delta example and I just made my config file look like this. However, I kept my pinouts the same. Essentially, I just renamed these top sections here. So my stepper X I changed to A, my stepper Y I changed to B, and my stepper Z I changed to C. I didn't change anything else here. Extruder is the same on any motion system, so I didn't change that. I'm not running a heated bed, so I don't have this in my config. You can see here we put in our USB ID, and then I changed my printer kinematics to Delta. We'll ignore these for now. So we can see here I've set up my ABCs. You can also see here, because we're using an SKR Mini, we do have TMC drivers and we can configure the current for those TMC drivers. So because I used a SKR Mini config file as a default, these pins are already correct. I can now communicate to each stepper driver on my SKR board, and I'm running them at 0.5 amps. You can see that all three of my steppers are running at 0.5 amps. For my extruder, I'm running the LDO pancake motor, and I'm running it at 0.25 amps. Okay, and we'll go through really quickly here what all these options are kind of briefly. You'll get more familiar with these as you play around with Klipper, but they're actually quite human readable. They're very straightforward. I find this much, much easier than Marlin. So for example, our stepper A, all we're telling Klipper is what pins are our motor connected to. And these are the UART pins on our board. Again, you don't need to know what these are. Klipper already has a bunch of default configs that you can already grab from. Okay, run current. This is the stealth chop, whether we want to use stealth chop or not. That's documented in the Klipper config. And if we go to our Klipper website here, actually, there is a reference configuration, if I can find it for this video. Let's see here, configuration reference. So this will tell you every single option in a Klipper config file. So for instance, what's stealth chop threshold? If we didn't know that, let's copy that, go to our Klipper reference, paste it in here. This is stealth chop threshold, and it'll explain it here. The default 0, which disables stealth chop. This will run basically loud or fast. We have stealth chop enabled by putting that 99999 parameter, as far as I remember. So we are running stealth chop on our Delta here. You can see stealth chop is turned on for each of our steppers. Okay. For extruder, again, these are the actual pins to connect our stepper motor essentially to the SKR. Each one of these you can see has a direction pin. The beauty of Klipper is we can change our direction very, very easily with this exclamation mark. We can simply reverse the direction of our extruder motor by either taking out the exclamation or adding an exclamation and saving this, and immediately the change will be reflected. If I had an X that was going in the wrong direction, I could come to my X or my stepper A or whichever motor was going the wrong direction. I can go to my direction pin here, and I can put an exclamation mark, save this, and it'll go the other direction. For a delta, you do need to put in your end stop position and your arm length. You can see there's a green here because they're commented out because I've already went through my delta calibration, and I will go through that in another video. But just know that you do need to provide these by default, and I have comments on here saying required. If I go to my delta configuration on the Klipper GitHub, you can see here these are entered in. End stop position and arm length. Again, if you don't know what these mean, you can copy one of these. Let's say arm length, for instance. Go to our Klipper reference, find it on the page, and it'll tell you what arm length is. We have upper arm length, lower arm length, and just generic arm length. So this is the length in millimeters that your arms are for your delta. So I actually entered in 215 for my mini delta. Position end stop is just the distance from your extruder, or sorry, from your hot end to your build plate. And I put in a rough number here of 190. So I've measured the tip of my nozzle to my build plate when my printer is homed. So when my delta arms are all the way up at the end stops. So this is your maximum build height, essentially, is what this is. And I put in 190. It's okay to put in a little higher than normal because when you do a Klipper calibration, it will use the probe to find this out. Okay, but by default, before you calibrate the printer, the very first time you need to put these two values in. 190 is mine because I have a 200 by 200 by 200 build area. And then I've put in my arm length as 215. You also need to provide your printer basics. So I'm using delta, obviously, so kinematics are delta. I put in a very, very low acceleration of 100 and max acceleration of 1000. My Z max velocity is 100. My minimum Z position here is -5 because I have a probe, and I may need to go below 0. So that's kind of a standard configuration on any printer. You may, when you do an auto level on a Cartesian or a Core XY, or even when I probe my delta, my build plate might be below 0 to the printer's actual configuration. So I put -5 here, which allows my probe to go below 0. Also, delta radius is required. Again, this is commented out for me because I've actually ran my delta calibration. The radius is half of your build circle, basically. So roughly I have 200, 180-ish, so I put 90 in here. Okay, I do have a probe. As mentioned in a previous video, I have one of those nozzle probes. So I actually told Klipper what my probe is connected to, which pin it's connected to, how fast I want to probe, and again, I've ran the calibration, so it's commented this out, but I set an offset of 0. You would start with an offset of 0, and you'll most likely not change this value. So if I go to SKR Mini E3 version 2 pinout, we will actually see a pinout. Let's open this picture up in a new tab so we can see it. You can find out the pinout number for all of, basically for any mainboard you're using. So I'm using an SKR E3 version 2. You can see I've plugged into my Z probe, and here is my actual signal pin, PA1. If we go back to my config file, PA1 is entered in here. So that's the beauty again of Klipper. It's very easy to figure out auto leveling probes and BL touch and all that kind of stuff because it's exactly what it says on the documentation for your board. So I'm using a probe on PA1 and I put that in here. I've also filled out this delta calibrate section because I am calibrating the delta with a probe. I'm doing an automatic calibration. I'm not doing a manual calibration. So again, I've given it my radius, which is half of my build area, which is 90, just like I've done up here. I've set my horizontal move at 35, which just tells the printer it does 7 points of a probe. So it'll probe the build plate 7 times to calibrate this. This tells the printer how high essentially it wants to move every time it probes. If you use the default 20, the build or your extruder might hit the build plate before it moves to the next point. So I put 35 in here. I believe the default is 20 or 25. And how fast do you want to probe? And I've just left the default as 40, I believe. The rest here are defaults for the board. And then you don't need to pay attention to this. But basically, this is what the calibration has found. It automatically calibrated all these values for me. I have never entered anything in the green. And you can see here, do not edit below here. These are auto-generated values. Okay? And I know this is a lot of information. When you build your first printer, you will learn a lot about this. And it is very straightforward. A lot of this is very, very easy to read and very easy to understand. And once you build your first printer, it's very easy to build your second, third, and that type of thing. Okay, so we can save that, and we can now see I've connected. A quick rundown on Mainsail. Again, it's pretty straightforward. G-code files are here. I have a bunch of G-codes that I've been printing and doing testing with. There's a console here, just like Octoprint would have. You can set commands in here. When you do PID tuning and all that kind of stuff through Klipper, it's all very well documented. History, we can see all my prints, how much print time my printer has. I've already printed 8 hours here on my little mini Delta. If we go back to the dashboard, we can see, temperatures. You can see I've added those temperature sections for my Raspberry Pi and my Mainboards. You can see what my processor temperature is on my Raspberry Pi. You can see the temperature of my processor on my SKR. And I don't have a heated bed, so I only have an extruder temperature here. We do have Z offset as well. So this is baby stepping. So as you're printing, you can actually change your Z offset. If your printer nozzle's too close to the bed or too far away, you can actually put in an offset here while it's printing, and you can save this, and it will save that for your next print, which is really handy. You can see your fan configuration. A really awesome thing too here is if you go into machine and go down to the bottom, we can actually see our end stops. So I did home my printer, and it's turned the motors off so that you can see my arms have sagged down a little bit. If we go back to dashboard and I home all, I've homed my printer. If I go back to this, you can see my ABC motor end stops have triggered because I've homed. And you can see my probe is not activated, so it's open, which is correct. So generally when I set up a printer, I'll make sure my end stops are actually correct, and I'll make sure that when they're not triggered, if I go here, that they should all be open. If they are triggered in here, but they've not been pressed or you haven't triggered them, then you just need to reverse your end stop, either reverse your actual wiring, or you could go to the printer config, and it's the same thing here for end stops. You can actually go into your enable pin and put in this exclamation mark. Actually, I believe it's enable pin, which does your reversing. So you can see here my enable pin on this is I got an exclamation mark. So if you find out your end stop has been triggered incorrectly, you might just have to come in here and put in an exclamation mark. And the way to tell that is just by querying your end stops, making sure that they're triggering. A lot of times when you build a printer, the very first time you come here, you might have like all your end stops triggered, but your end stops haven't been touched, and you'll need to reverse them and come back here and make sure that they're open before you home the first time. Okay, we also have an emergency stop here button at the very top. And if we go into the cog here, this is how you can configure your interface. So I've named my printer. You can actually show Z offset all the time, which I've enabled. I've themed my interface just with the colors of my printer. You can add or remove what's shown on your dashboard, and you can do that for specific devices. So on mobile, do you want it to show different things, or on a tablet when you view this web page? This is where you would set up your webcam. You cannot run a webcam on a Raspberry Pi Zero. It's not fast enough to run Klipper and a webcam. However, you can certainly do it on a Raspberry Pi 3 or a 4. This is where you set up custom macros as a button. This is basically control, and these are defaults that you can see on your dashboard. So if I go into my dashboard, these are the defaults you can see here. You can customize these. Okay, so in a nutshell, that is how to install Klipper on a Raspberry Pi. Set up a generic config file and connect the two and kind of get started with Klipper. It's the easiest thing to do probably is just jump in. If you have an old Ender 3 or something like that, that's the best to play with and learn. Or if you're following along with the Delta build, I will provide a config file for this Delta, which you can then customize for your own build. If you have any questions or would like more clear documentation or another video on a particular part, maybe that didn't make a lot of sense, let me know. I'm happy to do that. All right, everyone, please subscribe and comment below. Thanks.